As surprising as it might seem, scientists are human too. If you think we're like Star Trek's Mr. Spock, you'd be very wrong. Many scientists get excited about what they're doing. They often work long hours because they love the subject. However, it's also how we make our living, and we are judged on our research output. This is assessed by our ability to produce something new knowledge in the case of academic science, or maybe a new product in the case of industrial science. This can create a conflict of interest. Scientists might feel pressure to get a positive result because it directly affects their career. This can lead to scientists unintentionally, and on rare occasions deliberately, interpreting data in favor of the results that are beneficial to them. To guard against these problems, there are some safeguards. Blinding and placebos. One common method to avoid bias is to use something called blinding. A good example to help us understand this is to consider what happens when a new drug is tested in patients. Let's suppose we want to test a new drug to treat depression. One source of bias might be introduced because the patients may feel better simply because they've been given something that they believe will make them better, even if the drug is ineffective. Another source of bias is that the doctors assessing whether the drug works or not may be inclined to believe the drug has worked even if it hasn't. The solution to this is that when the drug is tested, some patients receive the drug while others receive a placebo. That's a tablet that looks like the tablet that really does contain the drug, but the placebo contains no active drug in it. A code is used to determine whether each patient gets the drug or the placebo, but neither the patient nor the doctor knows whether the patient has had the drug or the placebo. This removes bias because neither the patient nor the doctor knows what the patient's received until the trial is completed, and the results, which have already been registered and stored, are in fact decoded. This type of analysis is often used in science, when scientists have to use their judgment to interpret results, rather than there being a clear and unbiased measurement using laboratory instrumentation. The second way we'll look at to try to remove bias is to use improved data collection and analysis methods. In this approach, we'll try to remove bias by removing human subjective judgment from the process entirely. For example, instead of looking at two sets of images and asking a scientist to judge if there's a difference between them, it is possible that computerized image analysis software can be used instead. The third way for removing bias is to make data accessible to all. This is an emerging trend in which scientists make all their data widely available. Traditionally, scientists have just published summaries of the data, but by making the underlying data available to anyone, it allows other scientists to re-examine how well the data has been analyzed.